Hello, everyone, and welcome to another episode of Observable Flutter. My name is Craig Labenz. I'm your host, and today we're going to be exploring, at last, how to organize the sloppy code of zombie logic, pathfinding, and steering in my zombie shooter game, built, of course, with Flutter and Flame. And the package that I'll be using for that today is none other than Flame Behaviors, which was written by esteemed community member and one time, I think only one time, Observable Flutter guest, Wolfen. So I'm excited to get into this. I have not studied the package at all yet, so I'll be learning from scratch with you all. I have, however, been putting a little bit, I'm trying to remember where I left this project 2 streams ago, and it seems to be in something of an incoherent state. So that is all some of the fun that we have to look forward to today. But before we get too far into that, folks, remember, this is the Flutter community. Let's do what we do best and be great to each other, be warm and welcoming to everyone, and certainly not overly critical of other technologies and the like. Can anyone find my cursor? Oh, there it is. Great. Okay, lovely. Let's see here. I do have one thing I need to check. Let's see, content. Sorry, folks, a little bit of, oh yeah, there we go. Okay. All right, everything seems to be in order. All right, and yeah, let's get started here. So how's everybody doing today? I've actually do have another thing or two I need to check before fully diving in. My apologies. Okay, I don't think chat is working. Is chat turned on? This on. I don't know how to do this. I'm going to ask someone who helps me. All right, my apologies. We're not off to the fastest start here, but all right, let's get into it. Hopefully we'll get chat turned on shortly, and then you'll all be able to help me learn Flame behaviors, because I think I'm going to need it. So as you can see, actually the first thing I did a second ago was update the Flame version, and that didn't break anything. So that was a simple migration. And I did that because Flame Behaviors mentions that it requires a newer version of Flame than I was using. I hadn't updated since starting this project, so I was long overdue. So that's done. And then I ran the game to make sure that it did, in fact, oh no, that was right. Oh yeah, no, it needs to be a version that actually exists. So then I ran the game and remembered, oh yeah, Lucas and I, who he was helping 2 streams ago, last time I worked on this project, we seem to have left this game in something of an irregular state, because there is better performance when there's 100 zombies on the screen, but they don't avoid each other anymore, which was the behavior that made it slow. So I hope we didn't make it fast by simply turning off the expensive feature. But that I'm also going to spend just a second trying to remember. So this is a PR of the changes that were made the last time I worked on this. And I remember us putting collisions every zombie got their own hitbox, whereas before I had like had this kind of irregular algorithm to have the zombies not step over each other. And then cleanup movement, I think that was the method where, so this is in on collision. Interesting. Yeah, cleanup movement was supposed to prevent them from stepping on each other's space. I think we maybe renamed it last week because by the time on collision is called, they've already moved. That's why they're colliding. So cleanup movement would need to like move them back, which is what I'm guessing the intersection points. And we ran out of time to actually analyze where the intersection points were and cleanup. I don't think cleanup works because we're not passing in the intersection points, or we are passing them in, but I'm not using them. I remember us not having time to make use of that. Okay. Well, that's fine. And I will just kind of carry on. All right. So flame behaviors. Let's see here. It's time to, where's the documentation? Okay. Collision detection, event behaviors, getting started. Well, I'll read the getting started, which I did read on stream a long time ago when I mentally queued up this package to play with on a stream, but I haven't looked at it since and basically don't remember anything. Okay, so there you go. You add it. I'll do that. So an entity is the thing that we need to know about. The entity is the building block of a game. It represents a visual game object that can hold multiple behaviors. So a zombie would be an entity, and behaviors would be things like hunting the player, not stepping on the toes of other zombies because they're very polite, stuff like that, which in turn define how the entity behaves. Great. So define a custom entity by extending entity, and then we pass the list of behaviors to the superconstructor. Great. And I'm guessing then, I vaguely remember wondering about this aloud last time as well. I'm guessing we attach an entity to a component, which seems to be the next thing that this talks about. So types of entities, there are two. The base entity is a generic thing that can be used to represent any game object, so potentially non-visual as well, or a positioned entity that is based on the position component. Great. So these entities use the entity mixin that provides base functionality for an entity. I see. Okay, these entities, both of them. Okay, interesting. Oh yeah, so my sprite entity extends sprite component with entity mixin, and then I guess there's also a position entity mixin, maybe. Yeah, because sprite component is not a position component. It's higher up, I think. Or maybe not, I don't remember. These entities use the entity mixin. Oh yeah, that's what I just said. If you want to turn any component into an entity, you can use it. For instance, if you want to turn a sprite component, you can do the following. Flame game can also have an entity. Great. All right, so then we get to behavior. A behavior is a component that defines how an entity behaves. Oh, I'm getting some feedback on chat. Can we enable it? Excuse me. Sorry, folks. I really want to get chat turned on because I want to say hi to you all. Hopefully that's coming soon. Behavior. A behavior is a component that defines how an entity behaves. It can be attached to any component that uses the entity mixin. So, right. And handles a specific behavior. Behaviors can either be generic for any entity or they can be nicely tailored to a specific one. Behavior composition. Each behavior can have its own components. Components for? Can have its own components. This word's confusing me. Have its own components for adding. Oh, I just can't read. Each behavior can have its own components for adding extra functionality. So behaviors can have more components. Oh yeah, I remember having this remember this too. I'm guessing that component is not a Flame component, but I don't know, and we'll find out. I'm guessing this is a component unique to this package. So we can have entities and behaviors, and then behaviors can have components. We've got this tree of things. So for instance, a timer component can help a behavior component do something at a certain interval. Looks good. Note a behavior is a non-visual component. The word component is getting heavily overloaded in this context. Describes how a visual component, an entity, behaves. Therefore, a behavior cannot have its own behaviors. Okay. Yep, I remember reading that. What's next? The following sections will show you how to use Flame behaviors for common game development tasks, like handling game input or collision detection. Flame behaviors also have some conventions on how to name and organize your code. Naming conventions and code conventions. Well, I definitely want to look at those. Uh-oh. Yeah, boy. Yeah, boy. Okay. Oh, there's a video? Oh, I wish I'd watched that ahead of time. Oh, boy. Oh, they made a way better Pong than me. Okay, main dot dot. All right, so let's see what we can deduce from this. I don't see any Flame behaviors shenanigans going on yet in the Flame game here for Pong. Handle keyboard component has collision detection on load. Yeah, so this all looks like generic Flame. Yeah, 1 second here. Oh, wait. I think this might turn it on. Anyone save? All right, I think I just turned on chat. Can someone try to say something? Does chat exist now? I'm going to refresh this. I have, I think you might have to refresh the stream. No, I still, oh, there it is. Hey, all right. I found the checkbox. It was under a menu that was hard to read while I was also talking. Hello, everyone. All right, great. Okay, so creating the paddle entity and its behaviors. All right, here we go. So positioned entity. Interesting. And so the positioned entity gets a child component, and that's what draws the actual paddle and contains, oh, the hitbox is also a child of the entity and is not attached to the component. By the way, Wolfen, author of this package, hello, great to see you. And I look forward to many snarky tips. The snarkier, the better. All right, so with keys, interesting. Oh, this is going to bind how it's controlled, I guess. Okay, so here we have a behavior. Right. Nice. Okay, so this is also just really good design. So we have a special constructor for this paddle class that basically returns a behavior, or it attaches a behavior to this moving behavior attribute, which is decided as required. Okay. So that's a field. Yeah, on this class, I guess it's just omitted or I'm not seeing it. Okay, so the moving behavior is required on this positioned entity, and the helpful constructors attach that appropriately. Love it. Yeah, okay, this is great. This is nice. Now, I'm guessing we're going to learn more about the keyboard moving behavior as we scroll down. So let's do that. We start by defining a paddle, blah, blah, blah. Yep. We just understood all of those constructors. Looks good. All right. And then there's the hitbox. So one thing to note is that the paddle has a rectangle hitbox as one of its children, which allows for collision detection. Because the paddle does not have its own collision behaviors, we don't need to do anything else. I guess that means because the logic of colliding lives in the ball class. When we get to the ball entity, yeah, we'll showcase. Great. All right, moving behavior. This is what we're here for. Happy to help. It's a team effort out here, right? That's why we call it open source. Let's see. Andrea, I'm not sure which. I have a question. Why does Flutter only work with material design? The fact is that you can't build an app without using material design. And my question is, can you do it without material design? So yeah, this is worth talking about. Material design is kind of the default styling language in Flutter. That's true. The material library is built on top of the widgets library, and the widgets library is kind of unstyled widgets, but it's definitely true that there's a lot of functionality that lives in the material library that, you know, maybe in hindsight should have been put in the widgets library. It would make it easier to start from absolute scratch. The goal of the material library is obviously it's opinionated out of the box, which is different than like unstyled HTML. The goal of the material library is to be customizable enough where you can still tinker, you know, through the theme, which is kind of like Flutter's CSS. You can still tinker with each individual control and change their color and their shape and whatnot until you achieve a look that is distinctly yours and doesn't have anything, you know, the fact that you kind of have this archaeological, you know, you're building on the ruins of another city, like your styling is on top of material. That shouldn't really be obvious or visible or detectable to end users. That is the goal of Flutter's material implementation. And any feedback that you have as you pursue that is definitely welcome. So that's what I would say to that. Okay, so moving behavior, as described above, the moving behavior will be controlled by keyboard input. That's great. For that, we need to create a keyboard moving behavior.dart file that will live in the behaviors directory. All right, so we're going to need, I think we'll have the same kind of code organization. I'll make a behaviors folder and we'll start putting some stuff in there. So let's edit the file and add the following code. Here we go. So it extends behavior of type paddle, and paddle was the entity that it has to go on. Okay, so behaviors are maybe optionally typed. Has keyboard handler, has game ref. That's interesting. So these are like these are classic Flame things. Now I'm curious about the super class of behavior. Like, is it also just a component? I'm going to look at that shortly. Okay, so this has, they're just like other places to put, like on key event is still just coming from keyboard handler and update is the same method. So this is this materially different than another component if I had just nested a component on the paddle? Wolfen, that's my first question for you. The behavior can have a parent type, so its parent property will be strongly typed. Yep, that makes sense. That would be coming from here, and then the parent attribute, would be strongly typed. That's great. Jishank, hey, welcome to the stream. Okay, continuing down, as we can see, behavior is quite compact, only has one goal, move the thing up and down when pressed. That's great. Creating the ball entity and its behaviors. Okay, looks good. So here we have another positioned entity. And this is, oh man, I'm so curious. I need to check out the library. I want to look at these classes. Flame behavior, GitHub. I'm going to clone this. Come to Papa. Where is my terminal? There we go. Dev, git, I don't think I have make dir very good open. That's not how I spell very good open source. Very good open source. CD into that and git clone flame behaviors. The behavior is a component, so you can compose existing components into behaviors, assuming they bring a behavioral aspect to the behavior. Interesting. Code flame behaviors. All right, this I think will help. I'm going to move this back in the other window. And yeah, get out of here, doc. Run dart pub get. Maybe it's Flutter pub get. This probably depends on Flutter. All right, so we've got behaviors and flame steering behaviors. Oh, that's a separate package. Okay, I wonder if this is going to give us a bunch of off-the-shelf helpers. But first, we're just looking at base flame behaviors. And what is entity.dart? Here we go. This is going to be good, I think. Oh, right. CD packages, flame behaviors. Yeah, we do have to be in an actual Flutter package directory to run that now, don't we? Okay, so mixin, entity mixin on component. So entities will always be components, and this is coming straight from Flame. That's lovely. And let's see what else. I'm going to, let's kind of look at this real quick here. So find behavior. Find behaviors. That just looks at all the behaviors. And then what is this? Where type T? Interesting. Okay, so we can ask for just a certain set of our behaviors, I guess. Returns a list of behaviors with the given type. Okay, that's good. Oh, that's interesting. I'm guessing this means if we can return just certain types of our behaviors, that the idea is that the developer doesn't need to worry about how to organize how they attach all their behaviors to an entity, because you can just pull them out you can pull out the ones that you need at a given moment. And that makes sense. I'm still curious about the ordering of these behaviors and how that kind of gets thought about. Whoa, I've never seen this before. Very good packages. Oh, very good packages get -r works recursively. Wow. Okay, yes, exactly. You can look them up from the Flame component tree. Great. Yeah, and then you pull out the ones you need, or we can get a single one. So how does this work? Returns the first behavior found in a given type. Okay, so you probably only use this if you know you only have one. This will only return a behavior that has a completed life cycle, aka it is fully mounted. Great. And then, so you best know that you have one, because if you ain't got one, you in trouble. Yeah, because it's not returning a nullable thing, so that makes sense. And then the next one has behavior. It's checks. You can also, of course, then use that before calling find behavior. That's interesting to do that instead of just have find behavior return a nullable one. The different API design patterns available to us all. Okay, yes, entities are components, and the entity class itself has its own mixin. Great. And so super.children, these are, of course, the children components. So an entity is a component. Great. Priority key, yeah. It's interesting that it's only these. Yeah, so you wouldn't use it super flexibly with just any component. I mean, the constructor only takes these things. But I guess that's probably what the positioned entity is for. It'll take the other things. Oh, and then the doc showed us how to make an entity to extend like a sprite component. So that must be how this all works. Oh, the order is based on priority, a value from Flame's components. Was that factored into the find behaviors? Oh, maybe it's tucked in this Nope. Is priority, oh, maybe there was like a register, children register behavior if behaviors equals null. Oh, where do we add a behavior? Maybe they get inserted in order at the moment when a behavior is added. It's tucked into the children's system. Yes. Okay, great. Alrighty. So, oh, and then here's our positioned entity, and this has, yeah, all the other parameters that we would expect. And then what special things do? You have behaviors. We assert that children, behaviors cannot be added to, I presume we need the word positioned entity here, cannot be added to positioned entity as a child directly. Oh, I'm thinking, no, I'm not really sure why this is happening, because children is being passed up. So this constructor can trust the fact that children where type behavior. Oh, I see. I get it. You have to add behaviors in the behavior way, and you can't add them as children. Type safety wise, that would work, which is why there's this assertion to check. Got it. And then if behaviors don't equal null, add them all. Oh, add all. This must, right, that's the same method that a component has. So it must, let's see where this goes. Add all. It's still just adding component. All right, now I'm really confused. Add all adds these behaviors. Well, add all takes components normally, and it adds them just like children would be added. You know what? Actually, I don't, children. I actually don't think I have this fully straight in my head yet. Yeah, so children is behaviors. Children. Is children also where just like extra components go? If you call add on a component, let's check this out. I can't remember. Component. So where's the add method? This says add child and children. Yes. Okay, so this same list of children stores all of our components and behaviors. So behaviors are just kind of nestled right in there next to children. I think I'm getting that right. But then I'm not entirely sure why, because add all, it's not doing, is it doing something special? We're immediately in Flame here. This is just adding these behaviors like normal. So I'm actually not sure why this code is required. And Wolfen says children contains components, including behaviors. Yeah, that's what I had just concluded. Sounds good. The reason that we have this on the constructor is for a clear, readable. So the user can easily distinguish what's going on. But what I can't quite tell is there actually a behavioral difference? Sometimes it's as simple as it just is what it is. Okay. All right. All right, back to the code tree. So now let's look at, what's the name of this folder? Oh, in behavior. So this is probably just the barrel file. Oh, no, it's not. What? All right, so behavior is its own thing. Behavior is a component that defines how an entity behaves. Yeah, so we read this on the docs. Behavior can have its own components for adding functionality, however, cannot have its own behaviors. All right. So behavior has a parent type that extends entity mixin. That makes sense. And the behavior itself is also a component, which I think I saw earlier and was kind of losing track of. But that makes sense because it intersperses itself with the children. There is no difference, but if we ever want it, it won't be a breaking change. Okay. Okay. So add a component. Behaviors can't have entities. So this is these rules that we have. Contains point, contains local point. Okay, so behavior doesn't have much on its own, but there was a behaviors plural. Oh, that was the barrel file. Never have a brain try to do string matching because you'll fail. All right, so collision behavior. This will be an interesting one right out of the gate. This could be how I start to have the zombies not step on each other again. So this behavior is used for collision between entities. The propagating collision behavior propagates the collision to this behavior if that entity is colliding with the parent. If the entity that is colliding with the parent is an instance of collider. Okay, I'm going to read that again. Propagates a collision to this behavior if the entity that is colliding with the parent is an instance of collider. I don't know what that is. What is collider? Oh, it's the type on the behavior. Got it. Got it. All of these non-one letter types are both better than one letter types and confusing because I'm used to really unhelpful one letter types. So there's collider and parent. Right, that all makes sense. And then it attaches to the parent. Looks good. All right, so we've got, we determine, are we colliding with the correct thing? And on collision start, blah, blah, blah. And this, right, is abstract. So we can define these methods ourselves. All right, I think I'm about ready to get started here. And then there's the behavior on mount, on load. So we attach these callbacks on collision, find entity, on collision, super on collision. Okay. All right. Let's start writing stuff. Reading comprehension is my greatest skill. You may be surprised to learn that I have poor reading comprehension. Let's do it. In the words of Rafiki from The Lion King, it is time. So let's add a dependency, flame behaviors. Ooh, the big 1.0. No bug fixes necessary. That's a flex to just be sitting on 1.0. I'm sorry, did I ship a perfect package that had no issues? That's so awkward. I hate when I do that. I've never done that. I don't know what that's like, but Wolfen apparently did. Okay. I don't really know how to do this yet, but let's find out. Flame behaviors. And I guess I can get rid of some stale imports. Oh boy. Oh boy. The first thing that we could do here is peek at the cleanup movement method, which apparently wasn't doing anything, because this is the code that I think we're going to have to bring, or I could. So there's three interesting things that a zombie does. It alternates between a state of tracking the user and wandering based on whether or not it is close enough to the user. That's the first and most primitive thing the zombie does. Then it has another behavior. Then as it walks, it like veers and stumbles. That's another thing that could be moved into the behavior system. And then the third thing is not stepping, like colliding with other zombies, not stepping on the same space. So any of those three things are potential candidates for migration to, you would recommend reading the collision docs to make sense of this. Okay, back to the docs. Any of those three things could be candidates. Oh wait, I was looking at Oh, docs or code? I guess docs, huh? Or where's that? Documentation here. Collision detection. Oh yeah, I don't think I've actually looked at this file yet. Okay, collision detection. Boom. Flame comes with a powerful built-in system, but the API isn't strongly typed. Components always get the colliding component as a position component, and developers need to manually check what type of class it is. That's true. Flame Behaviors is all about enforcing a strongly typed API. It provides a special behavior called collision behavior that describes the type of entity being targeted for collision. It does not, however, do any real collision detection. Yeah, so we're just filtering the results from the global system. That is done by the propagating collision behavior. What? Propagating collision behavior does real collision detection? I assumed the real collision detection would continue to happen in the core Flame stuff. I'm suspicious of my understanding of this sentence, again with the reading comprehension. The propagating collision behavior handles the collision detection by registering a hitbox on the parent entity. Okay, that's what it means. So it registers itself for Flame's actual collision detection. When that hitbox has a collision, the propagating collision behavior checks if the component that the parent entity is colliding with contains the target entity type, which is actually what I said the first time, specified in collision behavior. So this means that a collision behavior can say like we'd attach this collision behavior to a zombie, and it would register that it's colliding with other zombies. Oh, I'm blocking some of the words. Oh, maybe I can just be like really tiny. Itty bitty living space. Look at me. I'm still blocking some of the words, but less. So there are two main benefits of letting the propagating collision behavior handle collision detection. The first and most important one is performance. Oh, wow. By only registering collision callbacks on the entities themselves, the collision detection system does not have to go through any collidable behaviors for which there could be many per entity. We only do that now if we confirm a collision has happened. It's not obvious to me how this would be materially more performant. So I look forward to learning more about that. Oh. Yeah, no, Wolfen is not behaving. That's not in his DNA. So zip, zap, zoom. Oh, hey, a little... you don't happen to do improv, do you? So what I'm imagining is happening is that the core collision detection of like which hitboxes are overlapping with other hitboxes, that logic is still happening in Flame proper. And then in the old world, when two hitboxes are overlapping, each of their callbacks gets poked. And then in those callbacks, you might do something like say, if the other thing is the type that I want, then proceed with this new logic. And this system sounds like it's going to replace that a bit. But when we looked at its code, we saw things like, is this, just a similar type check? So, and then if this type check passes, then you're going to bubble down into all the callbacks. And that sounds like the same thing. So I'm curious about where the performance improvements are coming from, but we'll continue on. Oh, that is an interesting question. Ska, the 90s music style. Well, happy to have you in the chat. A style of music asks, is Flutter a sufficient language? So framework, of course, you mean, right? Dart is the language. But is Flutter a sufficient technology to create a very large application such as Instagram or Facebook? Yeah, definitely. Google makes many of its own large scale apps with it, and those are pretty large scale. So yes, like Google Earth. That one recently released in Flutter. Pretty exciting. YouTube Create, a very, very feature rich, very not just down the middle app, also made in Flutter. So yeah, definitely was the two most recent that I can think of. Okay, back to propagating collision behavior and the performance increase that I am not fully understanding yet. By only registering the callbacks, yeah, it doesn't have to go through any collidable behaviors. I guess I don't know exactly what this means, and that could be where it's coming from, for which there could be many per entity. I was assuming these are like the logic that you run in your on collision callback after you perform a type check, but I don't know. We only do that now if we confirm a collision has happened. Yeah, that sounds similar to what we do before. Wolfen, please enlighten me. The second benefit is that it allows for separation of concerns. This one certainly makes sense. You write code dedicated to a specific thing in a specific place, and it doesn't have to muddy up everything else. Each collision behavior handles a specific collision use case and ensures that the developer does not have to write a bunch of if statements in one big method to figure out what it is colliding with. This part makes super obvious sense to me. A good use case of this collisional behavior pattern can be seen in the example, where we have a propagating collision behavior that has its own hitbox. Wait, my entity collision behavior. So my colliding entity, so this is what, so it's attached to the parent and it's waiting until the parent runs into a my colliding. And then we put the logic on them here. Oh, my entity collision behavior sits right next to the propagating collision behavior. I kind of assumed that this would be a parent situation. Behaviors can't have other behaviors, so I guess that wasn't going to be the case. But I'm still not totally sure how these all talk to each other. This is interesting. Here we have, where we have a typo. There. That's okay. Your code was perfect, so the documentation is allowed to have typos. This part I would like to understand better, which I guess we can just look at the propagating collision behavior class. All right. I am going to do that. Although I'm also suspicious that I just want to start with the two. I want to start with like super arbitrary behavior and see how that works, not just collisions. So the wandering versus chasing. But I want to also look at the propagating collision behavior. I want to see how this works. So it is used for collision between entities. It propagates, I already read this, but I'm going to read it again. It propagates the collision to, oh no, I'm looking at the wrong thing. It was further down in the same class. Got it. This behavior is used to handle collisions between entities and propagates the collision through to any collision behaviors that are attached to the entity. So I guess it can just call like parent dot, what was that, children? There was something that like grabbed all the children of a certain type. So it could say parent dot find behaviors. The collision behaviors are filtered by collision behavior dot is valid, which is the type check, which is what the rest of the sentence says. And then you call on collision. Yeah, that makes sense. So this allows for strongly typed collision detection without having to add multiple collision behaviors for different types of entities. Without having to add multiple collision behaviors for different types of entities or adding more logic to a single collision detection behavior. Without having to add multiple collision behaviors for different types of entities. I don't fully understand this. Multiple collision behaviors for different types of entities. I guess, I mean, you would still add those to the component, but they're just not going to be in this class. I'm not sure what this sentence means. If you have an entity that does not require any collision behaviors of its own, You can just add the hitbox directly to the entity's children. If you have an entity, yeah. So that was like what we saw with the paddle, because the ball took care of reacting to a collision. Any other entity that has a collision behavior for that entity will then be able to collide with it. Yep, exactly. So the paddle was able to be collided with by the ball. So note, this behavior can also be used for collisions between entities and non-entity components by passing the components type to collider, right? Because entities are also components. So the parent to which this behavior is added should be a position component that uses the entity mixin. Okay. Flame behaviors come with the positioned entity, which does exactly that, but any kind of position component will work. All right. So the last thing, no, not the last thing. Oh, yeah, there was a comment on performance. So the performance is that instead of having the checks happen in multiple behaviors, it just happens in the propagation behavior. And that leads to a big performance improvement. So the checks, instead of happening in multiple, it just happens in the propagation behavior. Huh. Interesting. All right. I'm going to return to my previous size. I wasn't even in my final form. All right. Zombie time. All that collision detection stuff was fun, and I hope to get to it. But to get my feet wet, which is an interesting idiom, I'm going to get in the pool slowly. I am going to try to find the, zombie goal state. Yeah, where do you get switched here? So in the update method, we call update state. What does that do? Oh, this is where, okay, so update state. Yeah, this method should have been called like goal state. So this is the logic that I first want to convert to behaviors. And what it does is it figures out what is the path to the player. And then there's a maximum distance. And if you are under that maximum distance, you start wandering. If you are over that maximum distance, you start chasing. And set state to wander is a method because not only does it assign that value, but it does whatever the heck else. But like, zombies, they stumble around, they get lost, they're not good at their jobs. And so this is like some random noise code to make that happen. All right. So I am going to add a goal state behavior, and I'm going to add a new folder, one of those words that start with F, called behaviors.dart. That isn't what I wanted to do. Let's try again. I wanted to add a folder called behaviors. And now I can move behaviors into that folder, behaviors. And in here, because barrel files are so fun, let's export zombie goal behavior.dart. And this will be zombie goal behavior.dart. Wunderbar. And now in the zombie class, we can import zombies behaviors. Great. We'll alphabetize this. Goes there. All right. So this is not going to be a positioned entity. So I think if I have a class that's a zombie goal entity, should I first convert my whole zombie to an entity so I can attach behaviors to it? Or can I attach behaviors straight to components? I don't think so. I think I have to convert it the zombie itself has to be an entity, right? Actually, I guess we can just look at the behavior class. That will tell us. So behavior again, parent has to extend entity mixin, which the zombie does not yet. So that's the first thing we have to do. Oh, I'll never find the zombie file in the Flame behaviors package. Now will I? Okay, so zombie extends position component. Let's try to convert this to a positioned entity and change nothing else. And I think class declaration must have a body. Indeed. All right, that may have not broken it. Yes, I believe that is to answer the question, do I have to convert the zombie into an entity? And I think the game is still going to run, which is great. La da da da. Package was meant to be a you can add it to existing games type of package. And here I am, adding it to an existing game. Okay, didn't break. Added it. Good job. Successfully done. Which reward would you accept? So now I need to... Oh, so this means that it's not the zombie goal entity anymore. It would just be the zombie goal behavior. But that's going to have to extend... Is it behavior mix-in? Or just behavior itself? So it extends behavior, and the parent is going to be... so you are going to extend behavior, and that is going to come from Flame behaviors. And the type of this is going to be a zombie. And for that, we have to import the game. Well, that didn't work. Name zombie isn't a type. Well, then why did you let me import this file to fix that problem? What are you talking about? It's literally right there. Oh, okay. ID was just slow. Oh, there's more reading to do. I'm getting more homework. All right, we should read up on the naming conventions so your behavior names are not feeling out of place. Because zombie goal is not a behavior, is it? Yeah, I mean, I want it to be a behavior. Unless I don't understand unless I think the package is more broad than it is. I want to move the goal behavior off of the zombie itself and into this class. But let's read the naming conventions. Oh, wait, was that there? Did I see it? No. Oh, conventions. Coding and naming. All right. Now this is some high quality documentation. Okay, following name conventions are simply recommended. Indeed. Okay, good. Player extends entity. Enemy, bullet, yes. Putting entity on the thing. Bad. Great. Behavior. Action verb plus behavior. So jumping behavior. Good. Jump behavior. Bad. Okay. I'm not doing that yet. Well, let's look at some coding conventions. Entities should not contain any behavioral logic. Instead, they should be composed of behaviors. Sounds good? This allows for more flexible and reusable code. Entities should not do any direct rendering. Instead, they should add child components to handle the visualization of the entity. Woo! I am not doing that yet. Oh, yeah. Okay. So I see. All right. Zombie goal. Oh, I clicked the wrong one because you typed more. Zombie goal, bad. Moving to goal, good. Okay. That's fair. So instead of zombie goal behavior, this will be like goal-seeking behavior. How about that? And then I'll move the zombie goal state enum into here. How about them apples? Now, the positioned entity takes a behaviors iterable, which would go in the super behaviors. So here we will begin by instantiating a goal-seeking behavior. Well, I'll rename the file to goal-seeking behavior. You love that. Save the barrel file, goal-seeking behavior. Oh, yeah. It was never in doubt. So now we have an update method that we can call, which gets a DT. And we should call the super update, I think. Oh yeah, the linter says don't override and do nothing. Fair request. So now, actually, you know what? We're going to go back to one zombie, and I'm just going to watch this print something every whatever. So 100 zombies. Where are you at? Oh, I'm not in the right file. How did I not open? I thought I opened the world. There we go. Zombies tad 1. Run the game. Make the game happen. Yeah, very high quality documentation, except for minor typos. How dare Wolfen have an occasional typo in his second language? Just abysmal. Oh yeah, I forgot to put anything in the class here. Print seeking. Oh man, my editor is really just struggling. Okay, reload. Visual Studio would like to do the thing that you just asked it to do. Hey, all right. So we just, it's a component. We have an update thing. This is great. My computer does not. Oh, did I make these assets? No, these are from Kenny NL, a great resource. Yeah, it's like, what is even happening in the universe right now? What is going on? Okay, didn't I type kenny.nl and then that didn't load it? It went to some other website. I don't understand why. Every time I just type Kenny. Oh, I don't think I put the extra E there. Maybe Kenny.nl. Is this what I typed? Anyway, it's from there. They're great. Super good. Love them. Yeah. Made by Kenny. Okay, so you're telling me that again, when the human brain can't string match, then you get into problems. We've got a seeking intensifies zombie. Okay, here we go. Let's get some of this behavior out of the zombie, which has been the most poorly coded class in this game for an extremely long time. I don't know if splitting the code this way is going to be useful or not. We'll find out. Please tell me if you find this to be less readable. Obviously, I'm covering a bunch on the right. So this, no, I already hate it. It's the worst. I've never hated anything more. Okay. So update state. This was the method. Get out of here. Just go away. Update state. I suppose it kind of makes sense to... Yeah, I'll bring out the whole file or the whole function. So update state, there's going to be a lot of refactoring, I think, just to get this to work. Right, like all of this stuff isn't known. So this would be parent.position. And if we added has game ref to this, then we'd could say with has game ref, which I'll have to import. Okay, that works. Now, why do you not realize? Oh, because it doesn't know the type of the game. So that was like zombie game. Okay, that's good. And then line, we can just import that. I'll import all the utilities. I don't remember what the other ones are. Maximum follow distance. That would, of course, be a constant that we move to this behavior. So maximum follow distance. Looks good. World tile size. This comes from some constants file. All right, goal state. So that was a parameter right there. That's obviously going to come off of the zombie itself. And what are the other issues? Oh, set state to wander. That's a method that needs to move. Wonderful. Nothing here works. So wander path was a vector 2 that will go here. Oh, yeah, no, I got to keep grabbing things. So get random wander path. That method can obviously move. Oh, the zombie class going to get real small. We'll import random. I mean, we'll import math, and then I guess instantiate a random thing. I don't actually care. Just doing this for now. Okay. Set state to wander. All right, so here, yeah, I'm going to worry about this later. Like when this was called elsewhere, like in onload here, I guess that would just be in onload of the new thing. Yeah. All the references to this update state, I'm pretty sure we can just get rid of that. We'll worry about pulling out later. Wander started at, that was also I bet we can just grab all of these, huh? Okay. Random again. And wander length. Nice. Zombie class getting much smaller, and a more contained place for the wander logic now exists. Now, I'd also like... Oh, wait. So the documentation said don't have the entity render itself. Instead, have it add extra components. Wolfen, in your opinion, onload. What's happening here? Onload. So I'm adding sprites like this directly to the entity. Is that enough of a separation in your mind, or would you add another component that is like the zombie sprite component and handles this and is further separated? Because, well, I'm just curious which one you would recommend. But I'll worry about actually fixing that after we get your answer. Okay, so the behavior class now works, or well, we didn't have to. Oh no, we have to call update state. That'll end up being pretty important now, won't it? It's interesting that updates. Oh yeah, right. Okay, so I was thinking, why doesn't update state take the delta time? But yeah, no, it just doesn't use it. All it cares about is the distance. Okay. So let's fix the problems in the zombie class. The first one of which is here. So set to wander, that's a function that we moved into the behavior. So what makes the most sense here? We're in onload. So my naive thought would be to call in the entity class, we saw the method find behaviors, and then there was the singular find behavior. So I don't know if this is what we want, but goal seeking behavior dot, and then here we just call set to wander. But like this seems, I'm suspicious that this is a bad pattern. Regarding the previous question, Wolfen says, in general, I would choose to do it in a component, but it's up to you. I often have a render component for that stuff. Yeah, okay. So that'll be a stretch goal. Are you crying when you read this, or is this what I should do? It feels like, well, I don't know. Yes, it was an A or B question. Well, no, I guess I said, are you crying when you read this? So maybe yes, you're crying, or yes, this is what I'm supposed to do. If that is an onload, you can just do it in the onload of the behavior. Touche. But I think this question is going to still come up again later. Like if two behaviors need to talk to each other. Override, void onload. All right, what's the next problem? So in the wander method, we refer to a bunch of stuff from that. So let's look at where this wander method is called, because this is, yeah, right. So in the update method of the, oh, I don't, should I have chase stuff in there as well? Yeah, I guess I should. I mean, I guess it seems like all of this is all just going to move to the update method here. And then the wander method is going to move in. And the chase method will also move in. Apply movement. Oh yeah, now this is where we're getting into the code that I really didn't like before. I'm quickly moving all of my logic into this class. This is just going to like take over the entire zombie class, and then the goal seeking behavior class is going to be bad. So I think I don't want to move these in here. I think I just want to set the state, and then yeah, that's what I want to do. I'm just going to set the state. So I've got update, that's fine. Set state to wander, that's fine. Get random wander path, that's fine. And then this code, I don't think I want to put in here, because this is acting on the goal behavior, but I am only driving the goal behavior. So now we're getting back to the question that I had earlier. How should I think about something like this? Find behavior, goal, seeking behavior, dot goal state. Are you crying now? So you'd have three behaviors: a wandering, a chase behavior, and then a behavior that controls what happens. Okay, that makes sense to me. This class is about to sound like an abusive boyfriend or something, because it's going to be like goal seeking controlling behavior. And be like, get a load of yourself, all right? You don't have to be such a control freak. Goal seeking controlling behavior, or just goal control behavior. Still very, very toxic name. Do not date this guy. Let me tell you what. Okay, so that yes, yeah, separation of concerns does not equal moving over code. That is what I was just realized. I was moving over all the code and like, no, this ain't it. And so if we have a chase behavior and a wander behavior, should they each like short circuit if they detect that the goal state is not their own? So like in this goal seeking behavior class or file, if I have a few other classes, so I'll just grab the class definition. So we have the controlling behavior, and now let's have the seeking behavior. And then we'll also have the wandering behavior. And so wander is going to move to the wander method, right? You're going to go here. And they should be added and removed from the child entity depending on the state. Oh. Okay. That's wonderful. That's just great. So the update method of the wandering behavior is going to call wander. And it's going to pass the DT. And then we'll move over these wandering fields. They're hiding somewhere. Oh, I had already put it on the game controlling behavior. Yeah. Okay. So set state to wander, that feels like it should also be on the wandering behavior. One day I'm going to figure this out. Yes. Yes, yes, yes. Yes. Wolfen, you beautiful, beautiful man. So all the wander things are here. Set state to wander will also be called here. Now, we don't actually have to store the goal state anymore because it's just which thing is. So we may not need the enum. Interesting. When behaviors are added and removed, is there like ping ponging in and out of the game? Does onload get called every time they're added? I'm hoping yes. Because if so, then set state to wander could just be called in the wandering behaviors on load method. And I still have to figure out apply movement. Oh boy, that's going to be, things were so coupled before this all started. All right, so update state. Right, so I think what this is going to do now, instead of doing this, we can say we want to add the wandering. On mount gets called every time. On load only gets called once. Great. State could be on the entity, as that is a common thing. So do you think it makes sense to continue to have that value on the entity, or could it just be the presence of the entities? I guess it'd be simpler to have on the entity. Then we won't have to like look up whether or not a certain behavior is attached. Oh yeah, you are now goal controlling behavior. And then we're going to have zombie goal state. Goal state. Did I just delete it out of here? Oh, I commented it out. Okay, there we go. A lot of surgery left to get done here. So what we can do now, still in this toggle method, do you think it makes sense to have, let me read this question that I think is maybe going to answer. The switching of state behavior should probably be on the entity, as you can set it to wandering. And if the behavior, yeah, that's exactly what I was just going to ask. Okay, so this would be parent dot set state to wander, but it's going to do different stuff than the other one did. Also, I do need to quickly go back down to that and switch this to on mount. And do we have to call super.onMount? Yep. So set state to wander here is actually doing the stuff. No, I'm looking at the wrong method, like a genius. Get random wander path. Where's that one? I'm all over the place, folks. I hope this is slightly coherent. So set state to wander, there's going to be that method on the behavior itself, and then another one on the entity. I think that does make sense. So set state to wander can say, like, if, and then what was it? Has behavior, right? So if has behavior of the chase be, what do we call it? Seeking behavior. Oh no, it's called chase, not seek. What am I even talking about? So if you have a chase behavior, then how do we remove a behavior? Is there a remove? Hey, don't get too proud of yourself. Everyone's 10 steps ahead of me. Chasing. Oh yeah, all right. Chasing behavior. How do I remove one? Remove. Oh, it's just in the children. So I would call the remove method. Remove. Oh, but you have to like pass that an instance. I don't have, do I have to store, should I store the instance of it somewhere? Because I don't have it yet. I mean, I guess we can get it. Ooh, that feels a little awkward. Maybe not. Maybe it's what you're supposed to do. Find behavior. Is this what I want? Oh, now it's chasing. Is this what I want? Find behavior returns a nullable instance. I thought it, I don't think it does. It says if no behavior is found, it will throw a state error. Okay, yeah. Used to apparently. So set state to wander. So we remove the other one, and then we basically just have the opposite one here. So if you don't have the behavior, then we add a new, and this of course is going to be wandering behavior. We add a wandering behavior. I'd probably also want like some asserts, because well, it depends if I want this method to be idempotent or not, right? You could decide, you could set this up. So you call this method every frame, you just don't care. Or it could be like, you've decided you only call it when you're switching. And then it would be really weird if you didn't have this already, but that's for another day. So set state to wander. This is set state to chase, sing. I guess we can do to wandering. And then I need to change that method when I called it here. Set state to wandering. Okay, so set state to chasing. So if we have the wandering behavior, we remove it. And we add it down there. So if we have a wandering behavior, we remove it. And if we don't have a chasing, we add chasing. Okay. Confirmed that this is how we want to toggle the existence of behaviors. Wunderbar. Okay. This is going to be more organized, I hope. So the zombie, that's looking good. What's my next thing here? So in update state of, yeah, this was goal controlling. We need another method here. Oh, I didn't set the flag, which it doesn't seem like we need. I don't know if we need it. I'm not going to set it yet. So here we'd have parent dot set state to chasing. Then we already had this set state to wander method, and that's called an onMount. So this actually changes the state of the parent. So set state to wander, I think this will be called now like initialize wandering state or something. Initialize wandering state. And oh yeah. So the idea here in the kind of on tick wander method, it veers for a bit and then it resets how kind of errantly it's walking. So that's why this is getting called again. All right, then we still have the actual movement code going on in here. That's going to get moved out into another behavior for sure. And this is also where I'm going to be curious about like the behaviors are going to be dependent on each other, right? The movement behavior for the zombie is going to need to know about its wander path. And just maybe there's no way around that, or maybe that means I'm still not fully thinking with portals. What are my other red lines? So find the goal state. Aha, yeah. So in theory, we're not going to need this because the behaviors are going to call wander or call chase. So I think we can get rid of this. And then the chase method is, is there an onMount? Because this code of clearing out wander stuff in the chase method is like insanely awful, but it still needs to happen, I presume. So I'm wondering if there is an onMount that I can put in the wandering behavior. Yeah, that's in here. So how about void on dismount? No. Let's look at. Whoops. Get back here. Mount. Is there a removed? Is there a method for that? On remove. Oh yeah, no. So I wanted to do some cleanup state. If you remove a child and recreate, it doesn't matter. On remove. Thank you. Isn't it nice? Folks, I think I'm currently living in the future where LLMs who are like fluent with the documentation are conversational with you, and you just ask them, what's the method I need to call? And right now, Wolfen is my personal LLM. Thank you. May the ones and zeros in your brain stay forever aligned. This is really helpful. And I don't know how anyone codes without the author of the packages that they're using on a phone call with them. Answering questions in real time. This is great. Void on remove. Override. Presumably. Okay, so now I just saw this behavior or this logic that needs to happen here, I presume. Oh, wait, you were talking about destroying and adding a new one. Right. So this whole thing I just did is pointless because I'm not reusing the object. So wander path and wander delta degrees just get destroyed by the garbage collector. And then I make a new wandering behavior. So this was totally irrelevant. Okay. Yep. It's pointless. Great. This does support the theory that I'm not a single person, but either an AI or multiple people. There's a super great book. What was that called? Blind Sight, I think, that has a Blind Sight book. Yeah, it's like in an open commons book. You can just get it for free. I'm pretty sure. I can't read, so I got it on Amazon or on Audible and had someone read it to me. But this is a super fun book about first contact, and it's super transhumanist, and there is a character in it with who is multiple characters. So everyone should read that. Okay, so this chase method needs to move to the chasing behavior class, and then update is going to call chase. This really just keeps sounding like I'm doing some banking or something. Oh, chase doesn't take the delta time? Oh, it does. It just also takes the line, the path to player. Path to player. Yeah, isn't that like kind of trivially calculated, but where do I do it? There we go. Path to player. I guess you don't really need to take the path to player anymore. You can just deduce it yourself. And the position here is the parent position. And we have more methods to do. That's great. So nice. Yeah, this whole, what did this do? Cache movement this frame, set from position to sub last position. Oh yeah, that was for that was performance stuff from last week. That will be interesting to carry forward. Game of the year? Yeah, well, I got a couple days left. So also the game totally stinks. Other than that, it's probably a great contender for game of the year. How hilariously broken will the game be if I were to run it now? And it would compile. No, it wouldn't compile. Oh, that's right. There were a ton of red lines in the behaviors file. Okay, apply veer to path. Let's look at that method. Wow, just terrible. Holy smokes. This is going to force thinking about code organization in a way that I was not doing before. And I was just slopping all of my pig feed into the same bucket. It was not good. Yeah, I almost want like a veering behavior as well, as opposed to just chasing. Like, I need to rethink movement on this zombie so holistically, because veering, I mean, maybe veering is just how the zombie chases, so it does belong here. I guess I'll start by putting it here, and then maybe further organization will reveal itself. Yeah, a package about code organizing is making me think about organizing code. That's crazy. Alan source. I don't know if that's how you intend. It could be Alan. I'm going with Alan's source. Alan source. I'm glad you're enjoying it. Welcome. So I think I'm going to try to keep. I'm just going to keep varying stuff in the chasing behavior. for now. That was a good sentence. And worry about it later. So vir started at needs to, all right, so probably all of these vir ing. Oh yeah, there was like lurching. Oh boy. Oh boy. Oh boy. These will go up top. Thank you. Thank you. Debug pathfinding. See what I really want. Let me tell you what I really, really want. Anyone in their 30s who was alive in the 90s knows that I just evoked one of the all-time classic songs. Also, people sometimes know songs that were written before they were born. So maybe anyone knows what I'm goofing around about. But what I really, really want is to have this like movement object, which could be as simple as vector 2, that is kind of passed through a series of modifiers. And so first there's the and the behaviors not being able to be nested is, oh, we got one. All right, great. Everyone knows the song. Wonderful. This is what I really, really want. I want a movement representation, which is maybe just a vector 2, that is kind of passed through a series of modifiers. And because right now, again, this chase modifier is still just like going to contain a lot of the ugliness that used to be in zombie. And that will be a little better in that it will be separated out from the rest of the ugliness. I guess I'll start with that. And then fixing the chasing behavior class will just be the next goal. We'll do this in bite-sized chunks. I think I just cut some code that I yet need to paste. Oh, I did paste it. So you're saying then that value, which I'm guessing you mean is the movement vector that would get passed around to all the behaviors, that could live on the entity, and that is how Flame steering behavior does it. Oh, right. Okay. Well, first, once I understand this, then that'll be maybe what I do next. I'm going to finish this refactor. I've only got 28 minutes left. In theory, this is just a matter of copying over a bunch of bad code and then watching it run from a different place. So I think I can get it done. And then maybe in the next stream, we'll convert it again to steering. And I'll stop initializing new random classes at some point in the future, but not today. All right, there's more red everywhere. Oh, there's one down here. What do you, oh yeah, no, I'm still waiting on those. Okay, move along path. Oh gosh, this is so nasty. So debug. Yeah, so debug here. That'll go on the behavior. I don't even know if this makes an ounce of sense. Like literally any sense to put, because debug was to render stuff or not. No, we're not putting it here. This is just crazy talk. I'm going to comment out debug pathfinding and figure out what to do with that later. So debug pathfinding. Okay, now we're just down to the moving methods. Move along path and apply movement and apply lurch. I think that needs to be its own behavior. So I'm going to have a new one that is moving behavior .dart. And I'm going to grab some stuff. And it's going to be moving behavior. And we'll import. I know there's a lot we got to do. So sue me. All right. You know I need to import flame behaviors. Get over yourself. Then we need to import flame components, and we need to import the zombie game. Okay, so that should be redundant. What? Zombie game doesn't import? Oh, right. That's not the top level barrel file. Okay. All right. Moving behavior. Here we go. So move along path. What does this method do? Path to player. Wolfen, what's your intuition? What are the other? I think I'm just currently living in a horrible no man's land in between flame behaviors and flame steering behaviors. And things are going to be really stinky until I get out of said no man's land. Apply movement, apply lurch, and move along path are the methods. So move along path takes a path to player. And that is actually, again, well, was that modified? So this is where this is the crux of what I didn't like about my old system, right? Move along path takes a line, and I called it path to player. But really, because this is what was going to actually move the thing, it was, if we look at where it was called, which has now been copied into this chasing behavior class, it actually was passed path to take, which was after the veering had been applied. So maybe this needs like a late vector 2 that is the path to take, and the job of the chasing behavior class is just to set this. The point of this class is to set this for the moving behavior. I will probably I'll probably outgrow this. I will come to not like this thing, but that would mean path to take is called here. Apply veer to path. What's that? What are you mad about? Line, you take a path. Path to player. What are you mad about? The value of type line can't be assigned to variable. Oh, okay, fine. Line. Okay, and then move along path is not going to be called here. And then in wandering, what did you do? So you had a wander path. So this could also maybe be like the path to take. Late line, path to take. And these could even be like a typed mix-in. What if I had mix-in path finding behavior on behavior, and you just have late line path to take? And then y'all use that mix-in, and that's not where I meant to put it. Actually, I also don't know if this can work. I didn't read that error. This might be a dead end. Okay, what are you upset about? Oh, okay, yeah. We just need to not double implement this. Uh-oh. Nope, still a problem. Can't implement both behavior zombie and behavior entity mix-in. Oh, yeah, that's fine. Zombie. Okay, now we're good. So this path to take is what we're setting. And so now down in random wandering behavior, path to take will also remove. We'll just use it from the mix-in. Hit the wrong key. Here we go. So with that and path finding behavior. So wander, then we're not going to call apply movement. We are just setting, it's not wander path anymore either. It's now path to take. Vector 2. Oh, this one went in the other direction. Really? Apply movement took a... Oh, right. It takes... Yeah. So you move along a vector 2 because you already know your own origin. The path to take, I guess that should like also be a vector 2. It shouldn't be a line. But that's going to be a really nasty refactor. It needs to be done, but not today. What is the easiest way to bridge this gap? Where did does apply movement only get called from? Yes, it only got called from move along path, and move along path gets called from chase. Wow, this code is the worst code I've ever written in my entire life. What? Oh, it also got called from wander. So everything went to apply movement. Both chasing and wandering went to apply movement. Is that right? Apply movement was called in move along path. This is the worst code in the universe. Move along path. So chasing definitely went in that direction via move along path, and wandering just went straight to apply movement. Interesting. So what did move along, or what did, whoops, where did, path to player, vector 2 normalized that. Oh, right, lines can just return their vector. Okay. So apply movement could begin to take a line and we'd pass in, we just pass in the path to player here. So this is the line to take. And then final movement equals line to take dot vector 2. Oh, no, this isn't going to work because this normalized part isn't always what we want. We don't want every game character moving the same amount. That is why apply movement took a vector 2. We need to stick with that. Oh, I think I have an idea. I think what I need to have happen is my pathfinding thing doesn't store a line. It stores a vector 2 that is the movement to make. Let's call it that. And now movement to make here, so this would be final, and then movement to make equals path to take dot vector 2, because we don't normalize in this one, but we do normalize here. So this was final path to take and then movement to make. Now I'm starting to sound like who sang that song? Every path you take, every movement you make. Apply movement. There we go. So that was, this one was normalized. There's no chance this code is going to run before the end of the stream. No chance in the universe. Path to take dot vector 2 dot normalized. What is your problem? Oh, path to take was already a vector 2. Wander path is a vector 2. Okay, then that means you would just be wander path. Oops. Okay. This code is not going to run today. We are not going to see this happen again. And it's going to be really easy to continue this effort the next time I stream in January. I'm like, what did I do last time? All right. So wander sets movement to make. That's the goal that it had. Oh, and then there was this apply lurch. Oh, goodness gracious. Did that get called anywhere else? No. All right. Lurching. I feel like this happened all the time. Yeah, that's why it was called in move along path. Everything was supposed to lurch. And the the delta time was just kind of truncated or not. All right. This is kind of what I'm thinking. I think I want to have an actual design document for how this class should behave. And it's going to basically show, like, apply movement. It doesn't make sense to have this vector2 and a delta time passed in, because the delta time is scaled up and down for like lurching purposes. So the zombies kind of take a step forward and then they sit around for a second while they collect themselves, and then they quickly take a step forward again. And that could just be collapsed into the length of the vector. So these two things as different parameters don't make any sense. And what I kind of now am thinking is, I think I still, maybe we're basically right there. Movement to make, this should just include any like speed buffs or debuffs that are going on for the zombie, right? When it's in its slow phase of the lurching cycle, we could say that it's kind of got a movement debuff. And that should just be factored into this variable as opposed to being a parameter here. Like, what is this even? Yeah, this doesn't make any sense at all. I don't like that. So apply lurch happened in move along path, and move along path happens only in chasing. So when they were wandering, I guess they don't lurch. That's a little bit of a surprise. But I think that means I can bring the lurching part into chase. So let's grab apply lurch. And I'm going to put this in and this was setting the movement state. Yeah, that's not going to work great. Holy smokes, that's going to break everything. So much rendering and state logic all completely interspersed. I briefly had a tiny bit of hope that this was going to run again before the end of the stream, and now I've lost that hope completely. So, yeah, movement state, like, that's terrible. I can't even copy this in here. Let's actually just read what it does and figure out what to make of it. So if the zombie is standing still, then we say if the date, so if the time since the lurch start, so basically this is if the lurch has totally if the lurch is totally elapsed, then we move into the stepping state. So that makes sense. This would be next. We remove idle. We start the walking animation. And then we reset our timer. That was if the zombie was standing. Okay. And then we return 0. This could have really used a comment, huh? I guess the idea here is, oh, the speed, because the zombie's standing. So the speed is 0. Okay, no, that actually makes sense. Otherwise, so this is if the zombie is stepping down here. We'd say if, again, the lurch duration has passed, then we remove walking and we start standing still and we set our state to standing. Yeah, this is going to need to be another behavior. Well, kind of not. I mean, I guess the switching, obviously we don't want to be like doing this animation toggling. But basically what this is saying is that even within chasing, there's a substate of standing or stepping. So chasing is, again, yeah, and I guess it makes sense that this would only be in the chasing mode. Also, wandering mode is for like off-screen zombies, so we don't really care what they're doing. They don't need the extra logic. So I guess apply lurch can go into chase. We'll need to then bring back out any concept of these animation components. But this movement state is going to be a thing on the chasing behavior class. And the movement state enum itself will move into the file. And what else did we have down here in apply lurch? Okay, so lurch started at, so let's grab all of those fields. Here we go, lurching, 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 looking good. So that goes all the way down to here. So those fields will, so we have veering and lurching. I'd like to separate this out more. I guess this could just be parent.remove and parent. Oh, let's make this a whole method. So let's have this be parent.use walking animation. And down here, this could be parent.use standing animation. I think this is probably not where this logic belongs, but that's going to be a headache for another day. Void use standing animation. Great. And then use walking animation. Use walking animation. And this would be add, and this would be remove. Okay, so now we can get rid of those lines. Okay, lurch duration, get standing lurch duration. That's a method that we'll pull in. There was another one, lurch step duration. Let's just grab both of them. It's clear we need them both. Undefined named lurch started at. Oh, this was in on load. Okay, so that is behavior that I'll move into on load of the chase thing. Override on load void super.onload. And let's get both of these. Okay, set veer, not assigned. Oh, where are you? You're in on load. Okay, set veer will just get called here, I guess. And apply lurch at last. Now we get to move along path. Is this method even still a thing? No, it's not called anywhere. Now I commented this out, and I'm not going to lie, I don't remember if I thought it needed to be moved. Oh yeah, I was making the moving behavior. I probably commented it out because I was going to put it there. Let's... Oh, wait. What did apply? So I just brought in, so apply veer, that one we're already using. I brought in apply lurch, and I'm just simply not calling it. So that's fine, but I need to call it. I think a move along path is going to be a, I want to multiply this by like a, yeah, so apply lurch on the speed, on parent.speed. That's what this does. We either, oh, we return speed. Why does apply lurch need anything? Yeah, this is actually just stale. I don't know why we had that. Fine, we'll pass it in. No. We would return parent.speed. That's what it is. Yeah. Because everything is typed, because that's the whole point of this library. So now in where I was just calling apply lurch, we don't do that. Well, apply lurch should really probably take a vector. Yep, that's what it'll do. That would be nice. That would be a lot cleaner. So apply lurch will take a vector. And here we just return vector 2.0. And then here we return the movement vector. Okay. Stop coding, play PUBG. I do like PUBG. Gosh, that's a fun game. If we don't talk again for a bit, happy holidays, Craig. You too, Randall. Another festival. Festivus for the rest of us. That's right. Hope is futile. It's feeling pretty futile right now. Ain't no doubt there. So apply lurch. Right, so you just take the movement now. See, this is a lot better. But apply movement's not even a thing. Where am I? Move along path. This method, I think I've ruled out the existence of this method. So I'm not going to continue editing that. Apply movement. You should not take a DT anymore. There is no DT. You just get some movement, and now I don't think I'm ever using the DT anymore, so that could be bad. Get unwalkable collision. This doesn't even look like it's being called, so we're not going to worry about that. Actually, there are no compile errors. I am 99.9999999% certain that I have incorrectly moved code into places, and I was like, I need to move this there and call it, and then like didn't call it, or called it in the wrong way, or probably 15 of those errors. But we're going to run the game because there are no errors now. Yeah. Right. Yeah, I'm not doing that yet. Well, I don't know if I'm doing that yet. I don't remember. In chase, no, in the chase method. So here we get the DT and never use it. So that's terrible. So the path to player, let's see what happens here. So it just sits in place. but it's, I thought it would be broken in hard to predict ways. I didn't predict that. So the problem could be literally anything, and I'm just going to call it for now. Woo! Game is running. Yeah, ship it. If I was Electronic Arts, then I definitely would, and the bug fixes would be DLC. Are you adding the behaviors to the zombie? Oh, am I? So I'm adding the goal controlling behavior, and the goal controlling behavior does call the methods that add the behaviors. So we are, yes. Great question though. Yeah, so your behavior ends up being nothing, or we end up getting no movement. I wonder if we can just spend a few more minutes on this. Like, what is your movement to make? Are you applying no movement, or are we not? Oh yeah, I'm not applying any movement, because move along path got commented out, and the other method was called apply movement. Can you restart the game, please? Whoa, it shot right off the screen. Rocket, zombies in flight. Woo! All right, so they weren't supposed to move at all, and then it went bonkers, and it moved really fast, and then it moved really fast in the other direction. Yeah, but where? So movement to make times, I guess let's just multiply by the delta t. I don't know. I think we had some assertion error as well, so that'll probably just come right back. Yep. All right. This is good for now. Basically the same error. Randomly applying the delta time on a line of code that received totally insufficient analysis. Shocker, that didn't work. Then there's also a problem in, is it here? No, where's my, there? Remove idle component. So I guess that didn't exist. All right, tons of stuff to fix. Zip, zap, zoom. Folks, this has been a pretty fun dive into Flame behaviors. I honestly think I could have had more success if I had just started from scratch with Flame behaviors. In hindsight, if I could whisper one thing in 2 hours ago me's ear, it would be make a zombie _2.dart file and use Flame behaviors in there. Maybe it still would have been terrible because I still would have been using zombie1 as source, as a reference code. But there's obviously more to do to pull this stuff apart. This code has been very, very, very bad, and soon it will be less bad. And I look forward to thinking about that more, but that will be a 2024 problem. Until then, everyone, please stay safe. Have great holidays. To whatever extent the upcoming season is a holiday season for you. If not, then, don't feel pressure, because, a lot of holidays are kind of overrated anyway. But everyone, have a great New Year's, and I will see you all in 2024.